Hello everyone, my name is Ansal Muhammad Abdul Kalam Azad and I am excited to share our research on comparing mixed reality and paper-based instructions for manual assembly, effects on performance and cognitive workload. This project was conducted at the University of Texas at Arlington in collaboration with my colleagues Ishwar Prasad Sridhar, Tazim Ahmed, Mateen Gazempur Anaraki, Russell Abdullah, and under the guidance of my professor Dr. Mahmood Rahman. Let's start with the background. Manual assembly tasks like building machinery or assembling equipment often rely on paper-based instructions. These use 2D diagrams which can place a high cognitive load on users who must mentally translate those into 3D actions. Mixed reality or MR offers a more immersive and intuitive alternative by providing step-by-step 3D instructions directly in the user's field of view. MR could potentially reduce error and cognitive strain. Our objective was to compare MR-based instructions with traditional paper-based methods to see how they affect performance and cognitive workload in a manual assembly task. Now let's talk about the experimental setup and test plan. We designed an experiment involving 10 participants aged 21 to 37, which were divided equally into two groups. One group used the MR-based instructions delivered through the MetaQuest headset. You can see the MetaQuest 3 headset in the figure 4. The other group followed traditional paper-based instructions. So the task was to assemble a simplified Lego blue monster truck, which is shown in the same figure 4. We pre-assembled most of it, leaving 20 pieces for participants to complete during the test. Here's how we ran the study. Each participant began with a demographic survey and training on their instruction method. Then they completed the assembly task while we recorded how long it took and how many errors they made. Afterward, they filled out standardized surveys. NASA TLX to measure cognitive workload, PSSUQ to rate usability, and a user perception survey. You can see from figure 5 the MR interface from MetaQuest 3 headset. The MR group also completed pre- and post-task simulation sickness surveys to assess any physical discomfort. Now, going to the results section. On average, MR group completed the task faster, about 11 minutes, while the paper group took around 13.5 minutes. The MR group also made fewer errors, 6.6 on average when compared to the paper group, which was 8 errors on average. Though the differences weren't statistically significant, likely due to a small sample size, the trends suggest that MR may offer performance advantages. In terms of the cognitive workload, the MR group reported lower levels of physical demand and frustration on the NASA TLX scale. This supports our hypothesis that MR may ease cognitive strain by eliminating the need to mentally convert 2D diagrams into 3D actions. As for usability, both groups gave similar ratings. The MR system scored slightly higher in terms of clarity and interface quality, but participants did mention concerns about visual resolution and comfort during prolonged use. To wrap up, while MR didn't significantly outperform paper-based instructions in our study, it showed promising trends in reducing errors and cognitive load. Participants found the MR interface useful and engaging, despite some hardware limitations. Future work should explore this further with a larger sample size and improve MR hardware. There's great potential for using MR in industrial training to make instruction more intuitive, efficient, and user-friendly. Thank you for watching, and I'll be happy to answer any questions or discuss the project further. Thank you so much.